In this video, I'm going to run through how to do all the different kinds of confidence intervals on your calculator, and then also how to put in sample size calculations. So I'm going to start off here. This was slide 22 in the 7.2 video. It was a one prop Z interval with a sample of 10,847 women, 55.2% of whom said that they breastfed, and so we needed to find a confidence interval for the population. Okay, so first thing I need to do is figure out what 55.2% of 10,847 is. So I'm going to do 0.552 times 10,847. And you do need to round this to a whole number, just whatever the nearest whole number is. 0.5 rounds up, so that's going to be 5988. Okay, so I need to do the one prop Z interval. I'm going to go to Stat, over to Tests, and the one prop Z int is way down at the bottom. There it is, A. So I'm going to pick the one prop Z interval, and my X value is 5988, and my N is 10,847. The confidence level for this problem was 90%, so 0.9. And then I'll go down to Calculate and hit Enter. So this tells you your p-hat, which we already knew was 0.552. It tells you your n, which we already knew. I'm not sure why it shows you both of these. But then the confidence intervals here in parentheses. This is proportions or probabilities, so 3 significant digits, 0.544, and this would round up to 0.560. With proportions and probabilities, if you give more places, it's okay. Now let's look at a Z interval example. So this is slide 40 from 7.3. Manager of a paper company. We've got a sample of 36 reams, mean time for the sample of 1.5. We have a population standard deviation of 0.3, so we're dealing with a Z interval. So let's look at how to put that in. We need a Z interval this time, so Stat, over to Tests. This time I want number 7. I can go down to number 7, or you can just hit 7. Either way, I'll go ahead and go down to number 7 here and hit Enter. And I want this on Stats, so I'm going to move that over and hit Enter to move this over to Stats because I have the mean and the standard deviation. Alright, standard deviation for the whole population they said was 0.3. The mean is 1.5. N is 36, and my confidence level on this one is 95, so 0.95. Get all of that put in, go down to Calculate, hit Enter. The mean and standard deviation were given with 1 decimal place, so that's what I'm going to round to, so I'm going to make this 1.4 and 1.6. And then they give you the X bar, just in case you didn't know that already. We did in this case, and the N. I want to also show a Z interval with data example, so I'm going to do this one from slide 45. We have a list of data, but we also have a population standard deviation, which makes it a Z interval. This time we need to put the list of data in first, so I'm going to go to Stat, but then we need to go to Edit to put that data in. I've already got my list cleared out, so I'll put my quiz scores in. 14, 23, 26, 27, 28, 31, 33, 35, and 37. Okay, once you've got those in, you can go ahead and hit your Stat button, go over to Tests. We need a Z interval again. This time I'm just going to hit 7. This time I need to make sure that I've chosen data, so I'm going to move this over to Data and hit Enter over there. It still asks for the population standard deviation, which we have, so that's 6.7. If you need to, you can change the list here to collect data from other lists. I put mine in L1, so I'll leave it there. You should never touch the frequency, leave that at 1. My confidence level I need to change to 0.9 for 90%. 0.90 would work as well. And then I'll go down to calculate and hit enter. And so this time we didn't have an X bar, so it gives it to you. And it gives you the sample standard deviation as well. We gave it the population one, it's telling us the sample one. And these were all whole numbers, so we'll round to 1 decimal place. This will be 24.5 and 31.9. Now we'll do a t-interval example, pretty similar, but it looks a little bit different. So this is slide 67 from 7.4. Study found the body temperatures of 106 healthy adults, so that's our N. Sample mean of 98.20, sample standard deviation of 0.62. We only have the sample standard deviation, so we need to do a t-interval. Okay, so I'm going to go to Stat, Tests. This time I need a t-interval, which is right under the z-interval, so number 8. Pick that. I need this over on stats because I do have the mean and the standard deviation. I'm going to go, the x-bar was 98.20, and the sample standard deviation was 0.62. N was 106. And the confidence level is 95, so 0.95. Go down to calculate and hit enter. We were given a mean and a standard deviation to 2 decimal places, so we'll do the same when we round. 98.08, 98.32. And a data example with t-intervals. So this is the quiz score one where we don't have a population standard deviation, so we need to use t-interval for it. So we'd go to Stat Edit to put the data in. I already have the data from the z-interval example, and they're the same numbers, but if you didn't, you could go ahead and put your data in there. And then we'll go to Stat Tests. This time I'm just going to hit 8 because I know t-interval is 8. You could scroll down and hit enter. I'm going to move this over to Data. This time I don't really need to put much in. It's a t-interval, so I don't have a population standard deviation. Make sure the list is the correct one. I did have that in L1. I don't need to mess with the frequency. The confidence level I do need to adjust. It's 90, so 0.9. And then down to calculate. And the quiz scores were all whole numbers, so we'll round to 1 decimal place, 23.9, that'll round up to 9, and 32.5. And if you needed the mean and the standard deviation, the calculator has figured those out for you along the way. I'd also like to look at how to put the sample size formulas in. So this is slide 30 from 7.2, where we found sample size for a proportion. So I'm going to look at how to type that formula into the calculator. Alright, so you can pretty much just type this one in order. I need inverse norm first. So I'm going to go second vars to get to the distributions menu. Going to go down and pick my inverse norm. I need 0.02 divided by 2. Close the parentheses. This is where the second power goes, so I'm going to use the x squared button over here. That's where the second power goes in this formula. And then I need to multiply by 0.15 and 0.85. You can use parentheses for multiplication like I did in the slide, or I like to just use the times button so that I don't get the parentheses mixed up with other things. So times 0.15 times 0.85, and then I'm going to divide by 0.025 squared. If you want to, you can put parentheses around the 0.025. You wouldn't actually have to since it's just one thing, and then square that. So really you just type everything in order, hit enter, and then remember, no matter how small the decimal, you always round up when you're finding n, so that would round up to 1105. And let me run through that one more time if you have the newest version of the calculator with the stat pop-ups. You just need to be a little bit more careful with your inverse norm command. So I'm going to start by going into the distribution menu, so second vars, and down to inverse norm. And so here's where yours is going to look a little bit different. The area is where you put the 0.02 over 2. So 0.02 over 2, or I could just divide that and say that it was 0.01, either way. And then for the mean and the standard deviation, with the other calculator, we just left these off so that it went to the default. With yours, you'll have to actually enter them. You may have something else from another problem entered here. What we need for this is the default, which is 0 and 1. That's the standard normal distribution, which we mentioned briefly at the beginning of the last chapter. So whatever you've got here, put in 0 and 1, and then we'll go down to paste. And it will paste all that into that screen, and you've got the screen that scrolls so you don't see everything at once. So from here it's the same. Your inverse norm command's a little bit longer there, but otherwise it's the same. So I'm going to hit x squared to square that, and then I need to hit times 0.15 times 0.85, and then I'm going to divide by 0.025 squared, so up to you whether you want to put parentheses around the 0.025 or not. I won't. 0.025 squared, hit enter, and you should get the same answer. And don't forget to round up. You have to be a little more careful with the mean sample size calculations and getting these put into the calculator. So I did have a quick screenshot in the PowerPoints on the calculator, but here I'll go ahead and walk you through this example from slide 52 in 7.3. So with these, since the second power is around the whole fraction, you could mess with extra parentheses and type this all in at once, but I find it easier to do the inside first and then square it. So I'm going to go ahead and go to inverse norm, so second vars to get to the distribution menu. I'm going to pick inverse norm. We need 0.05 over 2. Notice this time there's no second power there. I need to multiply by 10,000. Again, you can use parentheses for multiplication, but with all the other parentheses, I prefer to just use the times button so I don't get it all mixed up. And then we're going to divide by 100. Okay, that's the inside, that's the fraction, and so I'm going to go ahead and hit enter. And then I need to square that, and I can just go hit the x squared button. It will automatically call up the previous answer, and then I'll hit enter, and there you go. And so sample size always gets rounded up, so that'll be 38,415. And one more time on that one with the newer version with the stat pop-ups. So same thing, we're going to do the inside first. Second vars gets me into the distribution menu. Go down to inverse norm. This time I need 0.05 over 2, so 0.05 over 2, or just 0.025, either way. And again, mean and standard deviations should be 0 and 1 for these. And then go down to paste. There's my inverse norm command. I'm going to multiply by 10,000. I'm going to divide by 100. And that's the inside. I'm going to hit enter. That's only the inside. I still need to square that. So I'm going to square that answer. And 38,415.